Okay, start. There we go. And I hope that works. Okay, so now don't write on this paper right here. I'll tell you when I want you to write on that paper. But I want to kind of take it back. We've been doing a little a squared plus b squared equals c squared to find side lengths. And now I'm going to switch over to
Cut the range out.
you what?
I got the runs out.
Well, that's good. See, did you wash your hands and everything?
Yes, I.
Oh man, I'm so proud of you growing up so fast. And that's all in the recording. That's really nice. So whoever's at home, this is why I don't like to do live stuff. Because if you do live stuff, they hear all of this.
I'm pretty sure there was a kid in the stall that had the runs though.
Thanks for sharing.
Yeah.
Oh, gross. Okay. Anyway, sorry, people at home. Sorry for watching this later. We are talking about that. Okay. So I want to take it back to the special triangle. So we talked about, the Pythagorean theorem, a squared plus b squared equals c squared. Now I'm taking it back to the special ones. In geometry, you talked about these special triangles. One was a 30, 60, 90. One was a 45, 45, 90. Okay, so I want to talk about those a little bit before I get to that little snowman page. So, oops, I don't want you to write this down. Don't write this down, don't write this down, don't write this down. What shape did I just draw? A what? A square. How do you know it's a square?
The line things around it.
Okay, that tells you they're all the same length. And then it's got 90s in there. Okay, so now I created two triangles right here, right? Okay, so I'm going to come down here. 45, I know my numbers. Okay, so basically what I'm doing is I'm taking this triangle right here and I just rewrote it down here. You don't necessarily have to write this one down. I'll tell you the one next to it I want you to write down. Okay, so this triangle right here, it's an isosceles triangle. And where this came from is I just took this square and I cut it in half. I did diagonal and created two triangles. Put this one right here. Okay, so we had a 45, 45, 90. Now, what do you know about these two sides? They're the same, right? So in geometry, this is what you did. You kind of put an X there and you put an X there. Just tell you that they were the same. Remember, it was a square, so all the side lengths are the same. So these two sides, it's an isosceles triangle. Okay, so if you had me for geometry, what I did then, each table, I gave them a side length, and I said, tell me what this is. So one table, theirs was 5, so they would have 5, 5, 5 root 2. The 6 table would have 6, 6, 6 root 2, 7, 7, 7 root 2. I was a million. They told me what my side lengths were without even doing any work. So this one right here was always longer by the square root of 2. That's how much longer it was. Okay, so if this was 10, this was 10, this was 10 root 2. If I gave you this side, you divided by the square root of 2. If I gave you this side, you multiplied by the square root of 2. So the square root of 2 was there, and you either multiplied or divided by it to get the other side. Now I'm going to change things up. So I want you to write this one down. Yep, I know. There we go. Okay, so now, and yes, I'm going to take all of this to that Radiant Snowman guy I just handed out to you. So now I'm going to do this. Okay, so those two sides are the same. My hypotenuse is 1. Its length is 1. So what would my other two sides be if that hypotenuse is 1?
Is 1 over the square root of 2?
It'd be 1 over the square root of 2. Simplify 1 over square root of 2 in your head.
Root of 2 over 2.
So remember, how did we do that? We multiplied top and bottom by the square root of 2. So you ended up with, okay, so that's the triangle I kind of want you to have down there. So when you were in geometry, I didn't have anything to do with fractions over there. I kind of left it as the one on the left. Didn't know my left and right there for a second. Okay. So now I'm saying your hypotenuse is 1. So remember, that square root of 2 was just what you either had to divide by or multiply by to get your other side length. So if that was 1, you divide it by the square root of 2. But you can simplify that kind of in your head. So I'm going to be using these values here in a second. All right, your next one. Don't write this down. What kind of a triangle do I have there? You don't have to write this down. What kind of triangle do I got? Equilateral. Yep. Okay, all the sides are the same length. What are each of those angles? 60, right? If a triangle adds up to 180, then that makes these all 60, correct? Okay. So I'm going to drop a altitude down here. Okay. What's that make these angles up here? Okay. So since this is a equilateral, if I drop an altitude down there, it just broke it in half here. Okay. So now I'm going to come down here and kind of do what I did. You don't have to draw this first one if you don't want to, but we'll draw the second one. Okay. So now, can you guys tell me, just based on what I drew up here and down here, what's the relationship between this side right here and this one right here? What do these two, what can you tell me about them? This one is half of this one, right? Because remember, when I started this, I had 3 sides that were the same, and then I dropped this down here. So what that did was cut that in half. So I know this is half as big as that. So in geometry, I did this. You don't have to write this one down because I'm going to do it a little bit different here. So in geometry, this is what we did. I said, well, if this one is this one has to be twice as big. Okay. And then if I go about the same thing I did before, I gave you all a side length, and I said, find the other one. You guys would have told me that, oh, that one is whatever this is times the square root of 3. So if this was 5, that'd be 10, 5 root 3. This was 7, that'd be 14, that'd be 7 root 3. So you didn't have to really do any work. You just had to follow your little tricks. Okay, this one I want you to write down. Okay, so same thing as I did the last one. I'm going to say my hypotenuse is 1. Okay. What's that shorter side going to be? It's going to be half as much, which would be 1/2. Okay. Now, what would my longer side be? 1/2 times the square root of 3. So if I take 1/2 times the square root of 3, I just get square root of 3 over 2. Okay, so I told you in geometry that, hey, this is going to look a little bit different when you get into pre-calc. On this one, it's what I gave you in geometry, but just is the same exact thing, except for I just said, hey, this is 1. Find my other 2 sides. Okay? So I'm kind of taking it back to your special triangles. Now, I gave you a friend. This right here. Okay? Now, once we get this all filled in, when we take a test and you need this, I'll give it to you. You won't have to memorize it, even though it's very, very easy to memorize. But you won't have to memorize this. Okay. So what I have here is I have this circle. And then you're seeing that this circle has these extra little points in here. If I told you that this circle is a unit circle, what do you think I mean? Very good. It means your radius is 1. So from here to here, it's 1. From here to any of these dots, that distance is 1. From here to the top, from here to the bottom, those distances are 1. So the radius is 1. So how would I get to this point right here? I would go over 1, 0. How do I get to this point up at the top? Somebody tell me. How do I get to this point on the left? And yes, I do want you to write these down here. How do I get to my bottom point? Okay, 0, -1, and then we're back there. So these points right here are those quadrantal angles. Okay, so we went 0, 90, 180, 270, 360, and then you just keep adding 90. You land in one of these spots. Okay. All right, so those are those 4 points right there. Now, what I'm about to do not do this. I will tell you to write when I want you to write something. Because if you do what I'm going to do, you're going to end up with lines all over the place, and it's messy. So don't do this. Okay, so now what I'm going to do is I'm going to take those special triangles and kind of put them on here. Okay, so don't do this. I repeat, don't do this. Okay, so we went over those special triangles for a reason, because I was going to throw them in this circle here. So this is 30. Do not write this. Just follow along. Okay, so this is why I brought back my little special triangles here. 30 is just the angle here. What's this length again? That's just 1. What's this length right here? It's the short side. Okay, 1/2. And then this length from here to here is your square root 3/2. Okay, so if I just pick up that triangle, draw it in my little circle here, and I say that's 30, these were your lengths. So how do I get to this point here? I go over this much, and I go up this much. Right this point by that first dot. Okay, so square root 3/2, if you type that into a calculator, it's like 0.8 something. Okay, so if you figure from here to here, it's 1. Well, then from here to here, probably about 0.8 something. And then half. Remember, all the way up to the top is 1. So if I'm up, that's about half. That's about half the way to 1 if I go all the way up. So those are just my coordinates there, and they're just in fractions and not in decimals. Okay. Don't write this down. Second dot. Okay. Second dot represents my little 45, 45, 90 little triangle. This is why I said don't make these triangles, because you had triangles all over the place. Okay, this length is what? 1. What are each of these? Okay. So how do I get to this point right here? I go over, write this, and I go up. And I know I'll switch out papers. I don't like the triangles on my paper either, so I'm not going to do it after I do this. Okay, so square root 2 over 2 is like 0.7-ish. Okay, so to get to this point, if this is 1 and this was my 0.8-ish, okay, there's my 0.7-ish. Same thing here. If I come up here, remember this was halfway, so yeah, it'd be about 0.7. Okay, last dot. I'm just putting my little 30, 60, 90s in here. Okay, but don't you do that. All right, so this is going to be 1 because it's a radius. Okay, short side is what? It's 1/2. So that left this side to be this length. So write this. Okay, so get that point on there. Okay, so remember the whole distance over here is 1. So yeah, that looks about halfway, 0.5. And then up here, remember that's about 0.8. So if I went all the way to the top, that was 1. So we're good there. Okay, so this will be my, don't write any of this, you already have this. -1, 0, 0, -1. 2 over 2, and this is okay. So this is what you have on your paper so far. Okay. Okay. One thing I'm going to do, I'm going to put in some degrees here. So this right here would be 0 degrees. This first dot, it just represents the little triangle I made in my little bow tie, and that was 30. This one right here was a little triangle with 45 down there in that corner. And this one right here was 60. So what you have to remember is that little dot isn't 30 degrees. It's just if I drew in my little triangle, that would be my little angle that's down here. If you think of the bow tie wise, that's what that angle is right there. That makes that angle. And then this one up here is 90. What's this one over here?
180.
Hey, 180. What's this one down here? 270. And then if I circle back, where am I at? It just goes back to 360, right? Okay. So this is all really you should have on your little snowman guy right now. And that's where I'm going to stop right now. I'm going to finish this out tomorrow. I'm going to tie this back into what you did yesterday. And then we're going to start graphing either tomorrow or Thursday stuff. For those of you that actually did the assignment yesterday, the graphs aren't going to be that intensive. I mean, it was a wave. It kept going and going. It goes on forever. It'll be shortened up when we do it. It won't look completely like that. So, all right. So we're going to stop there. Don't lose this paper. Some of you don't have friends, and this is your first one. So. You actually did.
Yes, I told you I did.
You didn't have to redo it online. Yeah.